we're now going on to page 50 in the limits chapter, and in this video I'll be starting the homework video guide with example number 10. And for example number 10, I need to solve the next few limit problems without sketching the graph of f. Now, the kind of functions that are given to us in example number 10, they're actually piecewise functions because you have more than one graph. Okay, so let's take a look at the question. The question is, I need to find the limit of f of x. Now, f of x is this piecewise function, and I need to find the limit when I'm approaching when x is approaching -1. All right, so if you want to find the limit for these kind of problems, you need to consider the left-hand limit, and you also need to consider the right-hand limit. Okay. Now, if you want to find out which is the left-hand side, or how do you start off with the left-hand limit? Look at the piecewise function. Take a look at this statement right here, x is less than -1. All right, so if you kind of visualize this on a horizontal line, here is -1. If you're less than -1, you are looking at the left-hand side of -1. What that means is this is representing the left-hand limit, or if you want to evaluate the left-hand limit, you need to look at this function here, x plus 2. Now, if I look at the right-hand side of -1, this represents x is greater or equal to -1, which is this part of the piecewise function here. So this part right here, x squared plus 1, that is the right-hand limit. So if I want to find the right-hand limit, I need to evaluate x squared plus 1 when x is approaching -1. All right, let's go ahead and write out the solution now. So if I'm trying to evaluate the left-hand limit here, I need to recognize that, okay, the left-hand side is this inequality, and the function that's on the left-hand side of -1 is x plus 2. So in order to evaluate the left-hand limit, I would do this. The limit as x approaches -1 from the left-hand side, and the left-hand function is going to be x plus 2. All right, and then this question is really not hard to evaluate. I take this -1 and I just insert it. I do a direct substitution because this is a linear problem. So then I get -1 plus 2, and that equals to 1. So that means the left-hand limit is equal to 1. All right, now I need to go ahead and evaluate the right-hand limit. Now the right-hand limit, I'm going to use a different color here. For the right-hand limit, I need to look at this inequality here. X is greater or equal to -1. If I'm greater or equal to -1, that's kind of like the right-hand side, so this is going to be the right-hand limit. And I am looking at this function because x squared plus 1 is represented when x is greater or equal to -1, which is on the right-hand side. So in order to write my right-hand limit statement, I would write out the limit as x approaches -1, but this time I'm approaching from the right-hand side, and the function that corresponds to the right-hand side is x squared plus 1. And for this question too, you can just do a direct substitution. You take the -1 and insert it for x, and you would get -1 squared plus 1, which equals to 2. Okay, so your right-hand limit equals to 2, and your left-hand limit equals to 1. So the left-hand limit does not equal to the right-hand limit because 1 does not equal to 2. All right, so what that really means is if I go back to my original problem, this part here in blue, the answer to that is does not exist, and that's because the left-hand limit does not equal to the right-hand limit, because the left-hand limit was 1, and 1 does not equal to 2. And that's how we can approach a piecewise function problem without actually sketching the graph. All right, so let's move on to the next questions now. Question number 2, another piecewise function. This time I have a rational function for the first part and a square root function here with a parabola inside. Okay, so the question is, I need to find the limit of f of x when x approaches 3. Okay, so in order to solve this kind of a problem, I need to evaluate the limit when x approaches 3 from the left-hand side of f of x, and I need to find the limit as x approaches 3 from the right hand side. In my previous problem, instead of writing out the symbols, I kind of just used these letters, left hand limit, right hand limit, just to kind of save time, but in this example I'll write out the full expression. Okay, so if I want to find the left hand limit, I need to look at this part right here. X is less than 3. This is like the left side when so when you have a number line and if x equals to 3, if you're less than 3, that represents the left hand side. So this is the function that we need to look at when we're evaluating the left hand limit. So if I rewrite my limit statement, x approaches 3 from the left, the function that I need to look at is the top function, which is x plus 1 divided by x minus 1. And this question right here is not too hard to evaluate because we don't need to use any fancy techniques here. We just need to take the 3 and plug it in, direct substitution. And if I do a direct substitution step, I would get 3 plus 1 divided by 3 minus 1, which equals to 4 divided by 2, which equals to 2. Okay, so with that, I can conclude that my left-hand limit equals to 2. Okay, I'm just going to erase this just to kind of give me a little bit more space here. So you can just pause the video and go back if you need to write out the full steps. Alright, now I need to evaluate the right-hand limit, and the right-hand limit is that's going to be valid when x is greater or equal to 3, because that represents the right-hand side of 3, and the function that represents that part of the piecewise function is the square root function. So if I need to write my limit statement, it would be x approaches 3 from the right-hand side, and then I would just write out the entire function here. And for this question too, I can do a direct substitution. So this would be 3 squared minus 5. 3 squared minus 5 is going to be root 4, and root 4 is 2. And then you'll know, so my right hand limit is 2, and that equals to the left hand limit. So I can finally conclude that this answer here is just equal to the value of 2. Sorry, this answer here is just 2, and that's because the left hand limit equals to the right hand limit. Okay, let's move on to question 3. Alright, so another piecewise function. Now that I've done a few of these questions, what I can do right away is if I see this part right here, I know this is going to represent the left-hand limit, and I know this part right here is going to represent the right-hand limit. So I can kind of speed up the problem now, because if I want to evaluate this limit as x approaches 0, I need to look at the limit as x approaches 0 from the left-hand side and the right-hand side. So if I want to evaluate the left-hand limit, it would be limit as x approaches 0 from the left-hand side, and the function that I'm using here is 2 to the x plus 2, and then I can do a direct substitution here. This will be 2 to the power 0 plus 2. That equals to 1 plus 2, which equals to 3. So 3 is my left-hand limit. And then I can do my right-hand limit, so that would be the limit as x approaches 0, but now I need to look at the right-hand side, and the right-hand side is this part right here, and I'll write that in black here. That would be 3 minus x squared. Once again, I can do a direct substitution there, so that'll be 3 minus 0 squared, and that's going to equal to 3. My right-hand limit and my left-hand limit are equal, so my final answer here is 3. Alright, so once you've done enough of these, you can probably speed it up and move it a little bit faster. Okay, let's move on to page 52, more limit problems. The questions on page 52, example 13, they're a little bit, they're different because these are one-sided limits. The reason why they're called one-sided limits is because the question is telling you to evaluate the limit as x approaches 3, in this case, from the right-hand side. Okay, so let's take a look at this. One thing that you might recognize is that if you did plug in 3 here as a direct substitution step, you would get 2 over 3 minus 3, which gives you 2 over 0. Now, although that doesn't give us a great answer, whenever you have a 0 on the denominator and your numerator is okay, this is kind of telling you that you're dealing with a vertical asymptote. Okay. Alright, so to put that into words, I was just saying that you should have a vertical asymptote when the denominator equals to 0. So this is what you should be thinking when you're doing some of these one-sided limit problems. The numerator is okay, but since the denominator is 0, you should be visually thinking that this is probably a vertical asymptote, and when you have a vertical asymptote, it either goes straight up or straight down. So you should already be thinking that before you kind of start these problems. Okay, so let's erase all this, and now let's find some other strategies to kind of solve the problem now. Okay, so when you have a one-sided limit problem, I would go ahead and draw a number line. Okay, so here's my number line, and the number that goes in the middle is going to be this 3. So this 3 would go somewhere on your number line. And since you're dealing with a plus sign, you want to look at the right hand side, okay? Because you're approaching this question from the right hand side. Alright, so after you do that, I would, okay, so this is your first step. Your second step is pick a number on the number line. Okay, so since I'm focusing on the right hand side, pick a number that's to the right of 3. A very good answer could be 3.1. So this is your pick. My pick is 3.1. Alright, and then the third step is just do a direct substitution, okay? So I can write limit here as x approaches 3 from the right hand side, so 2 over, now the value that I picked was 3.1, so 3.1 minus 3. Alright, so what I would do next is ask yourself, the numerator, is the numerator positive or negative? Well, it's positive. And ask yourself, what's the denominator? Is it positive or negative? Well, 3.1 minus 3 is positive. If you have positive over positive, the final answer is positive infinity. So your limit approaches positive infinity when x approaches 3 from the right hand side. Okay, so that's your answer. Let's go ahead and just kind of draw a graph so that we understand what the result really means. So if you went ahead and if you graphed y equals to 2 over x minus 3, visually the graph would look like this. There's a vertical asymptote at 3, and this is a very rough sketch, so maybe the graph looks like this and like that. Okay, so that's what the graph looks like. Now, when you're approaching 3 from the right hand side, I mean, you're following the graph and you're approaching x equals 3 from the right hand side, so you're going to positive infinity here as x approaches 3 from the right hand side. So this positive infinity is this answer right there. So this is what the answer looks like on a graph when you're approaching 3 from the right hand side. Good. So with these limit questions, when you get your final answer, in this case it was positive infinity, try to like visualize the graph. You can use Desmos and just draw it out, and hopefully your algebraic answer will match your graphical answer. Alright, let's move on to question 2 now. Alright, so question number 2, another one-sided limit problem. This is a one-sided limit problem because there's a negative sign here in the corner. And if I plug in 2 there, if I did a direct substitution step, I would get 2 minus 2. So the top is -1 and the bottom is 0. So the numerator is okay, but the bottom is not good. So this is probably a vertical asymptote problem again. So when you have these one-sided limit problems, once again, draw a horizontal number line. The number that goes in the middle is the number that you're approaching, which is 2 in this case. And since it's a left-hand limit, you want to find numbers on the left-hand side of 2. So in this case, I would pick maybe 1.9. Pick a number that's very close to 2, but not like too far away. So I think 1.9 is a very good number. And then you can do direct substitution here. So x approaches 2 from the left-hand side. I'm going to rewrite the problem here. And then let's do a direct substitution here. So it'll be -1 over 1.9 minus 2. And all you need to do is look at the numerator here. Is that positive or negative? Well, that's negative. What about the denominator? 1.9 minus 2, that's going to give me a negative result. And when you have a negative result divided by a negative result, you get a positive result, and the answer will be positive infinity. So that's your answer right there. Once again, if you wanted to construct a graph of this problem here, if you went ahead and used some kind of graphical device, and if you graphed this function here, it's a rational function, there's a vertical asymptote at 2, and perhaps the graph looks like this and like that. That's my rough sketch. And if you're approaching 2 from the left hand side, I mean, just follow this green line here. I mean, you're approaching 2 from the left hand side, and the height that you're approaching is indeed positive infinity, which matches that guy right there. Okay, let's move on to some more one-sided limit problems. Question number 3. Okay, so now that we've now that we have a decent background on this, now we can kind of jump into these problems a little bit faster. So I recognize that this is a one-sided limit problem. If I plug in -3 there, I get 0 on the denominator. So I know this is a vertical asymptote problem. Let's put -3 in the middle, and let's look at numbers to the right-hand side of -3. And a good number on the right-hand side of -3 is -2.9. So let's go ahead and do a direct substitution here. So if I did a direct substitution, I would put -2.9 on the numerator. The denominator would be -2.9 plus 3. So that's just doing a direct substitution here and here. The numerator is negative, and the denominator, well, this is negative plus a positive number, and if I do the mental math there, I will get a positive result. I don't care what the final result is, I just care that it's positive. Now, negative divided by positive is negative, so the final answer here is negative infinity. And if you have time, you should verify that by graphing the function. But I'm not going to for this. I'm just going to move on. All right, so question number 4. What happens with question number 4 is if I plug in the regular 2 there, I get 1 over 0. So that is enough information to tell me that this is probably approaching a vertical asymptote. Now, this question doesn't tell you to approach the left-hand side or the right-hand side, so you have to do 2 calculations for number 4. So you need to do a left-hand side. X approaches 2 from the left of 1 over x minus 2. And you also have to do a limit calculation when x approaches 2 from the right-hand side. So you have to look at both the left-hand limit and the right-hand limit. Okay, after that, I'm just going to draw a number line right here on the side. The number that goes in the middle is 2 because I'm approaching the number 2. And then you want to look at numbers on the left-hand side and the right-hand side. So on the left-hand side, I'm going to pick 1.9, and on the right-hand side, I'm going to pick 2.01. And I'm going to use these numbers to substitute here and there. All right, so if I go ahead and do that, I would get 1 over 1.9 minus 2, and the numerator is positive, the denominator is negative, so this is going to be negative infinity. All right, so if I move on to the right-hand limit, if I go ahead and do a direct substitution, I get 1 over 2.01 minus 2, and that gives me positive on the numerator, and I get a positive result on the denominator. So positive over positive is going to be positive infinity. Now, since the left-hand limit and right-hand limit, you know, they're not equal, right? So that means the final answer here is does not exist. All right. So number 4, the limit does not exist. Before I move on to question number 5, we just determined that the answer for question number 4 is does not exist because the left-hand limit and the right-hand limit are not equal. I mean, if you're drawing the graph of this, I mean, you have a vertical asymptote at 2. So if you want to draw your little vertical asymptote here, and maybe the graph kind of looks like this and like that. Clearly, when you're approaching 2 from the, I guess if you're approaching 2 from the right-hand side here, you're going to positive infinity, and from the left hand side you're going to negative infinity, and that's why the limit does not exist. So there's a visual representation right there. All right, let's move on to question number 5 now. Question number 5, very similar to question number 4. You have to do a limit from the left hand side, and you also have to do a limit as x approaches 0 from the right hand, I messed up there. This is the left hand side and this is the right hand side. Okay, so let's go ahead and evaluate those. And the way you do that for these kind of problems is you would take the 0, plug that in the middle of this number line, take numbers on the left hand side of 0 and numbers on the right hand side of 0, and some good numbers that you could pick are 0.1 and maybe negative 0.1. So I'm going to take this number right here, and plug that in over there, and I'm going to take 0.1 over here and plug that in over there. So if I do my direct substitution step, it will be negative 4 divided by negative 0.1. Negative on the numerator, negative on the denominator. I get positive infinity. Here's my final answer on my left hand limit. And then on my right hand limit, this would be negative 4 over 0.1. So negative answer on the top, positive answer on the bottom. And this will give me a final result of negative infinity. Alright, so since the left hand limit and the right hand limit, they're not equal, the final answer for this one is does not exist. Okay, so does not exist because the left hand limit and right hand limits are not equal. Alright, we want to question number 6. I hope this one should be a bit easier because this is just a one-sided limit here, and the number that I will put in the middle is 3. And since this is a left-hand limit, let's look at numbers on the left-hand side of 3. So a good number there would be 2.9, and then we take 2.9 and we just do a direct substitution there. So negative 1 on the numerator. On the denominator, it will look like bracket 2.9 minus 3 all squared. Now, I don't really care what the numerical results are. I care that the numerator is negative, and the denominator is always going to be positive because of that too, so that's going to be positive. Negative over a positive is negative infinity is for my final answer there. Alright, so let's continue on. Question number 7. Okay, so question number 7, a lot more work again because I'm approaching 4, but that means you need to go ahead and set up the individual one-sided limits. Once again, there's a power of 2 on the denominator there. That has, so the bracket expression is being raised to the power of 2, so the denominator should always be positive in this answer, or this question here. Now approaching that from the right-hand side. And once you do a number of these, you should get comfortable with your speed as well. So I'm going to put a 4 here, and then I need to look at the left-hand side of 4 and the right-hand side of 4. A good number on the left-hand side could be 3.9, and a good number on the right-hand side could be 4.1. And once again, you're taking these numbers and you're substituting them in. All right, so anyways, I know the numerator is going to be positive and the denominator is going to be positive, so that will give me a positive infinity. Over here, I know this result would be positive and the bottom is positive, so that's going to be positive infinity. So my final answer here is positive infinity. So that's my final answer there. The limit is positive infinity. Okay, let's move on to question number 8. Okay, so the questions are getting brutal here because I need to do both the left-hand side and the right-hand side for question number 8 as well. Okay, now question number 8 is a absolute value problem, and you'll notice that if you plug in a 3 there, you still get, sorry, I'm just going to erase some of this stuff over here. Okay, so if I plugged in 3 there, I would get 1 over the absolute value of 3 minus 3. That is 1 over 0. So the numerator is okay, but the denominator is not. So this is definitely another vertical asymptote problem, even though there's an absolute value sign there. Okay, so when you have an absolute value, these absolute value limit problems, this absolute value sign, the main strategy is you need to get rid of it. All right, you need to get rid of the absolute value signs. So these things I'm highlighting here, I'll try to highlight those in yellow. These yellow things, you need to get rid of them so that you can actually evaluate the problem. Now, in order to kind of get rid of the absolute value signs, you have to think about the absolute value function here. So here it is. The absolute value function is made up of two pieces. It's made up of this green piece, and it's also made up of this blue piece. Oh, whoops. Wasn't able to change colors there. So this blue piece right there. You have to recognize that this part right here is like your left-hand side. And this piece right here is your right-hand side. When you're dealing with the left-hand side, the function here is actually y equals to negative x. And on the right-hand side, the equation is y equals to positive x. Positive slope represents that positive linear line. So the way you get rid of the absolute value functions is that you need to have like a negative sign for the left-hand limit and just a positive sign for the right-hand limit. Okay. All right, let me erase this and let's apply that theory into solving these kind of problems, because the number one thing for a limit problem that has an absolute value sign is that you need to get rid of the absolute value signs. So if I do the limit here, as x approaches 3 from the left side, this function, it now becomes 1 over negative x minus 3 close bracket. And if I take the limit as x approaches 3 from the right hand side, this function over here now, it just becomes 1 over x minus 3. Okay, so that's how you approach these absolute value questions. You write two separate limit statements, one from the left hand side and the right hand side. And for the left-hand limit, you need to have a minus sign there, because the left-hand side of an absolute value function in terms of this graph is y equals to negative x, right? Okay, so now we can approach this question the same way that we approached the other questions. We would put 3 in the middle, and now we have a left-hand side, and now we have a right-hand side. A number on the left-hand side of 3 could be 2.9, and a number on the right-hand side of 3 could be 3.1. And the idea now is you take these numbers like 2.9 and just substitute them in. Okay. If I substitute those values in, I get 1 over negative 2.9 minus 3. Now the numerator is positive, but what about the denominator? Well, this part here in blue, that's going to be negative, and there's a negative sign there, so negative negative gives a positive result on the denominator there, so this answer here is positive infinity. If I go ahead and insert 3.1 into my right hand limit, I get 3.1 minus 3. I don't care about the numerical answer. I know that all I care about is that the numerator is positive, and the denominator here, well, that's positive as well, so that will be positive infinity. So finally, you can conclude that after all this work, that this answer here is going to be positive infinity, because the left-hand limit and the right-hand limit approach positive infinity. All right, let's move on to question number 9. All right, now I'm approaching a 0 from the left-hand side. This is an absolute value problem. So if I'm approaching this absolute value problem from the left-hand side, I need to rewrite the problem as x. And on the bottom, you get rid of the absolute value signs, but you need to put a negative sign there because you're approaching from the left-hand side, and then you just write down x. Okay. Well, I don't need to do a number line here, because if you factor those out or cancel them off, I'm left with 1 over 1 with a minus sign, which is negative 1. So negative 1 is my final answer there. Okay, let's move on to question number 10. Question number 10, another absolute value sign, but this time I'm approaching it from the right-hand side. So the limit as x approaches negative 2 from the right-hand side. Well, I just rewrite this as x plus 2. And when you're approaching the absolute value signs from the right hand side, it's pretty easy. Just drop the brackets and you're just left with that. And this one, you don't need to do any sophisticated work. The top and bottom are the same. They just cancel off and you're just left with an answer of 1. And feel free to verify those with a graphing calculator or Desmos. All right, another limit question here. This one's another brutal question because it's not a one-sided limit, so we have to approach it using a one-sided, or we have to approach it from the left-hand side and the right-hand side to solve it. Okay, let's do this. So now this is the limit as x approaches 2 from the left-hand side. So now my function would be x minus 2 divided by negative sign bracket x minus 2. And my other limit here will be the limit as x approaches 2 from the right hand side, and right hand side of an absolute function is a bit easier to deal with because you just drop the absolute value signs and you can continue there. The right hand limit is pretty easy to evaluate because the top and bottom are the same, so this answer here is just 1. Okay, and with the left hand limit, this is also just an algebraic process. You eliminate that. That's 1 over 1 with the minus sign out there, so this is going to be -1 as the final answer. And since the left hand limit and the right hand, you can conclude that this limit does not exist. Okay, great. Let's finish off this video by going over a question from page 50. For page 50, I need to sketch a graph of a function that satisfies all of the following conditions. Now, when you're given these kind of problems, I would always start with these dots that I'm highlighting in yellow. I mean, these dots are pretty much telling you to put dots at these coordinates 0, 3, and 3, -2, and -3, -1. So on your grid, go ahead and plot those points. I mean, this point is just right there. 3, -2 is here, so that's this guy right there. And -3, 1 is over here, like that. Okay, so plot those points first. I think that's probably the easiest part of this problem here. And then once you've done all that, I would go ahead and now start at the top now. Okay, so we're approaching certain heights when x is approaching 0 from the right hand side and the left hand side. So let's take a look at this guy right here. We're approaching 0 from the right hand side. So if I'm approaching 0 from the right hand side, it's approaching a value of -2, right? Or a y height of -2. Now here's -2. I would go ahead and just put an open circle here because there's a closed circle over there, right? So let's put an open circle at -2 because we can't have two closed circles. And whoops. And then what I'll do now is when I'm approaching 0 from the right hand side, I'm getting closer to a height of -2. So maybe I can just do that for now. Okay, and then for this guy, I'm approaching 0 from the left hand side, and I get to a value of a y value of 1. So I would take this y value 1 and I would just put an open circle here because the same reason as the previous one, there's a closed circle there, so I can't have two closed circles, so I'll put an open circle there and then just draw a function that's kind of getting there, kind of like this. So if I'm approaching 0 from left hand side, the height that I get to is 1. And that's all I can really do for now. Let's go ahead and move on to the third statement now, which is this guy right here. So when I approach 3, as I approach x equals to 3 from the left hand side and the right hand side, the height that I get to is 0. So so when x equals to 3, I would go ahead and put an open circle there because there's a closed circle there, and you can't have two closed circles at the same x value. So I would go ahead and just maybe connect that line there and maybe something like that. And that satisfies that condition there. Okay, and finally, I think we can move on to this statement right here. These two statements right here, two more limit statements. So I'm approaching -3 from the right and from the left. And so if I'm approaching from the right hand side, I get to a height of 1 there. So that's not too bad. I mean, I would put a open circle here at height of 1 and just connect that dot there. So that satisfies that part now. And then I reach a height of -1 when I'm approaching -3 from the left, like that would be fine. And that is one answer that does satisfy all the conditions here. Now you can always make up any kind of function here, like even like this part right here, that yellow part. I mean, you could be creative there if you want. The back of the book just has like a straight line connecting those. That's totally fine. Whoops. So if you want to do that's fine. If you want to draw a straight line here, you can do that as well. So you can be a bit creative with some of your functions there. But that satisfies all the conditions, and that concludes this video.